catalytic. What is the difference between the two? What is affinity? This is the basic of biosensors. Okay? You do some kind of research which is under affinity. Right? Like? You give me an example. But before that, let me ask you, what is affinity? Any idea? By the English, let's go by the English, guys. Okay, forget about the technical. What is affinity? Attraction. Yes, I have affinity towards Bernie. You know?
What kind?
In a good way, not. Guys, but anyway, so affinity means, you can say it like a lock and a key mechanism, and an example is an immunosensor. Do we agree on this? Right? An immunosensor is an antibody-antigen interaction. Okay? And why does that happen? Is because when anything foreign comes inside your body, the immune system of your body has a response, and it will produce antibodies against the foreign thing. It can be anything. It can be COVID or it can be cocaine. You know, it doesn't matter really, because they have sensors of cocaine where, you know, it goes inside your body and your body produces specific antibodies against cocaine. And this is published data. I'm not just like making this shit up. But okay, so we understand that. What is catalytic? Guys, who is catalytic? Wow. What is catalytic?
Something that reacts.
Something that reacts. Is the sensor that you are making catalytic or affinity? Catalytic. So mostly catalytic are enzyme based. Okay. So they have a reaction. Okay. For example, what is the reaction of glucose? It is, what is the enzyme used for? It is glucose oxidase.
Yes.
Right, GO, and glucose goes to gluconic acid, right? So there is a reaction happening. This is all the glucose sensors that you see everywhere, okay? They have this catalytic reaction. And always remember, in a catalytic reaction, you can have exchange of electrons, exactly, right? But what about chain sensor? There's no exchange of electrons when antibody-antigen join together, right? Okay, so how to detect something like this? Okay, we focus on immunosensor because that is what we do in our lab. It is a kind of an affinity sensor. But let me introduce one thing. It's called label-free. What is label-free? We own label. I need more. Please. Oh man.
100% correct.
Wow. 100%. Okay, label free, guys, means that you don't need any extra label, and the label can be like a gold nanoparticle. Can you give me an example of a sensor, specially used by women, that uses gold nanoparticles as the label? Strip, right? That female pregnancy strip, right? The lines are gold nanoparticles. So this is not label free. But how can you do electrochemical sensing? By the way, before I go into electrochemical, am I giving a class? Okay, little bit, guys. Electrochemical, what is electrochemical sensing? Before we go into label-free electrochemical sensing, what is electrochemical sensing?
A sensor based on which sensing mechanism depends on ion reaction, where this involves electron transfer.
Okay, yes, electron transfer, but not always. Not always. Yes, it goes from one electrode to the other, but on the electrode surface, maybe not always, in case of affinity. But electrochemical biosensors, if you very simply want to say, is apply what was it?
Voltage,
Apply a voltage, measure
current.
the current. Okay, this is the basic, right? Everything that you do after this is based on applying a voltage. Now, what kind of voltage can you apply? Okay, and then you can have measure the current. What kind of voltages? DC and AC, right? AC, DC, right? The band.
哇，圈着
没有，刚刚
Change the fan, change the fan.
And the
Yeah,
how's the class?
how's the class?
Yeah.
I just listen for 2 minutes. I can't give you the answer.
The honest answer is true.
Everyone has to write the report.
Report. Report what?
For the
Okay.
class.
Oh, for the class.
Yeah, and submit it to Professor.
The first one, professor.
No, no, guys, please, please. I am trying to recollect my information from before because I've kind of little bit. Anyway, so different kinds of DC. Can you give me an example of different kinds of DC?
Square wave,
Square wave,
linear sweep,
linear sweep, voltmetry.
differential pulse.
Okay, pulse, DPV, CV. All of this is what? All of this is DC based, right? And always remember that when you do DC based testing, you are causing some change, permanent change on the electrode surface. Okay? Because you are applying ETN or V, for example, for polyaniline, you are causing something. That's why the polyaniline is being deposited on the surface, right? The aniline monomer becoming polymerization going on the surface. So it's because, what do you use? CV?
CV
CV.
minus 0.2 to 0.9.
And you know what? We worked a lot, right, Chen, on like this range and all this stuff. You know, optimization obviously is important, right? But anyway, so this is the basics. Now we go on to AC. What is AC? Okay, let's go this way. Apply a voltage, right? You apply an AC voltage. Everybody agree? Okay, this is the voltage. What about the current? The current will look something like this. What is changing?
Phase.
Phase is changing, so phase change. What else is changing?
Amplitude.
Amplitude, right? The magnitude. Okay, this how would you use it? Let's say Z. Okay, it's not Z, sorry, what is it?
A.
Let's call it A. Okay, because Z is used for EIS, right? So let me just